Now let us see a part of the power processing unit which is generally a DC to AC converter. The DC to AC converter is generally used when the input supply available at the site is a DC supply and the output voltage required by the motor is generally an AC motor. So the DC supply may be a clean DC supply or a distorted DC supply. Clean DC supply is available from the utility and the distorted DC supply is available either from the photovoltaic cells or fuel cells. The output voltage of a DC to DC converter should be a sinusoidal voltage which is capable of variable voltage and variable frequency. So DC to AC converter is also called as inverter, which is generally of two types. One is either it may be a 6-step inverter or a PWM inverter. The output voltage of a 6-step inverter has a higher harmonic content which is not preferable in most of the applications, but it can be used in few applications where the harmonics limits are tolerable. But the PWM inverter output is an AC voltage which has less harmonic content when compared with the single 6-step inverter. But the distorted DC supply, if it is available from a photovoltaic cell or from the fuel cells, the voltage level which is obtained from the photovoltaic cell or the fuel cells is very less in magnitude, and that has to be boosted up to a level required by the motor, and so we require a DC to DC converter, which is generally a boost converter. So first the output voltage obtained from the photovoltaic cell or the fuel cell has to be boosted up to the level required by the motor, and that has to be inverted either by using a 6-step inverter or a PWM inverter. So a DC to DC AC converter is generally an inverter. The next subunit of a power processing unit is a DC to DC converter. The DC to DC converter is generally used when the input supply available at the site or at the environment is a DC supply and the motor which is used to control the load is a DC motor. So generally the speed of a DC motor can be controlled by varying the applied armature voltage. The applied armature voltage, if I require to get a variable armature voltage to the motor, then I require a DC to DC converter. So the main job of a DC to DC converter is to convert a clean or distorted fixed DC supply into a variable DC supply. So the DC to DC converter is going to get an output voltage which is generally a variable one. There are three types of DC to DC converter. One is a boost converter, a buck converter and a buck boost converter. In the case of a boost converter, always the output voltage will be greater than the input voltage. In the case of a buck converter, always the output voltage will be less than the input voltage. In the case of a buck boost converter, the output voltage can be greater than or less than the input voltage based on the duty cycle. The next type of a power processing unit is an AC to DC converter. The AC to DC converter is generally used when the input supply available at the site is a AC supply and the motor which is used to control the load is an DC motor. So AC to DC converter is nothing but a rectifier. The rectification option can be done in two ways. The input supply may be a clean or a distorted, and the clean supply either may be from the utility or the distorted supply either may be from the wind generator. Here I have two options to get a variable DC supply. One is the AC supply is converted into a DC supply by using a diode rectifier, and the DC supply output of a diode rectifier can be again given as an input to the DC to DC converter. By properly controlling the duty cycle of the DC to DC converter, I can get a variable output supply across the armature terminals of a motor. Or I can have a controlled rectifier which is generally a thyristor based control, where the AC supply can be converted directly into a variable DC supply by using a controlled rectifier by properly varying the firing angle of a controlled rectifier. So this AC to DC converter is nothing but a rectifier which has two options to vary the output voltage. One is either by using the DC to DC converter by controlling the duty cycle, or by controlling the firing angle of a controlled rectifier. The next important power processing unit is the AC to AC converter. The AC to AC converter is generally used when the source available at the site is a clean or distorted fixed AC supply, whereas the machine which is driving the load is an AC motor, which requires a variable voltage, variable frequency. So AC to AC converter is going to convert a fixed AC supply into a variable voltage, variable frequency supply. This can be done by using three ways. First method is the fixed AC supply has been converted into a variable DC supply by using a control rectifier by properly controlling the firing angle of the control rectifier. And the variable DC supply can be converted into a variable voltage, variable frequency supply by using a 6-step inverter by properly controlling the switches of the 6-step inverter. This is one method. And the next method is by properly having a diode rectifier, I can convert a fixed AC supply into a fixed DC supply, and by having a PWM control, I can have a variable voltage at variable frequency at the output side of the inverter. This is another method. The third method is by using a matrix converter, which is the recent technique which is used in order to convert directly the fixed DC supply into a variable voltage, variable frequency supply at the output side of an inverter. So here there are three methods: by using a control rectifier and a 6-step inverter, by using a diode rectifier and a PWM inverter, and the matrix converter. Matrix converter is a direct conversion of fixed AC supply into a variable voltage, variable frequency supply. The next subunit of the electrical drive system is the control unit. Till now we have seen power processing unit, power source, and electrical motors. The next subunit of the electrical drive system is the control unit. A well-designed controller should have several functions. The most basic function is to monitor the system variables, compare them with the desired value, and then readjust the converter output until the system achieves a desired performance. So it is something like a supervisory operation. The output, the speed of a DC of a motor has been taken as a feedback, and it has been compared with the set value, and the error between the set value and the actual value has been taken and processed, and that process signal is converted into a control signal by using a controller, and that controller will take a necessity action on the converter to get the desired performance. Hence, because of using a control unit in the electrical drive system, the overall system performance has been enhanced and the stability is also ensured. The complexity of putting all the system is based on the requirement. The control option can be of two types. It can be an analog controller or a digital controller. But nowadays, mostly we use digital controller because analog controllers have lots of disadvantages. It is very noisy, it is inflexible, and ideally infinite bandwidth is required. So, in order to eliminate the problems of analog controller, we have a digital controller which is very immune to noise, and it is very easily configurable. It requires only smaller bandwidth, which is especially decided on which is especially based on the sampling frequency. And if I use a digital controller, it may be a DSP processor or a microprocessor based digital controller, which is very highly flexible, lower bandwidth is required, and real-time implementation is very easy. DSPs can be performed very faster when compared with the microprocessors because everything can be executed in a single cycle. Complex estimations, especially when we go for a sensorless operation of any electrical drive system, complex estimations are required which can be performed very faster than the microprocessors, and state observer designs also can be easily implemented by using a DSP processors. Now let us see how to select the various components in the entire electrical drive system. There are several factors affecting the drive selection. The basic criterion in selecting an electrical drive system for a drive application is to meet the power level and the performance required by the load during steady state and transient operations. Certain characteristics of the mechanical loads may require a special type of motor. For example, in the applications for which a high starting torque is needed, a DC series motor may be a better choice than an induction motor. In the constant speed applications, a synchronous motor may be a better choice than an induction motor or a DC motor. So, first we have to study the torque speed characteristics of a load, and based on the torque speed characteristics of a load, I have to select the drive system. Then, what is the speed regulation that the load can accept? Then, what is the range of speed that we are going to control? Whether I am going to control the speed from 0 to maximum speed or only at the around the maximum speeds. if I want to control from 0 to maximum speed, then an induction motor cannot be a better choice, because controlling the induction motor at low speed is highly difficult. Then DC motor may be a better choice. Then what is the current of operation it is required? Say for example, if I want to operate the motor in only forward motoring and reverse motoring operation, then a single phase controlled rectifier may be a better choice if the motor is a DC motor. If I have to operate all the 4 quadrants, then dual converter may be a better choice if the motor is a DC motor. Then I have to, based on the converter ratings is also very important. If the machine ratings are higher, then the converter ratings has to be chosen little bit higher than the machine rating, otherwise it will disturb the entire operation. Then next is the transient operation requirements. Based on the values of acceleration, deceleration, the drive has to be selected. How much it has to accelerate in what amount of time, how much it has to decelerate in what amount of time, it is also important. Then how it is going to start, whether it requires very frequent starting and stopping, then whether the braking is required in the transient operation, whether reversing the motor is required in the transient operation by the load, all that decides the transient mode operation requirements. Then power source requirements. What is the type of source available, whether an AC source is available or the DC source is available at the load side. If an AC source is available and I have a DC motor to be controlled, then I require an AC to DC converter. If I have a DC source available, then I have an AC induction motor to control, then I require an DC to AC converter. Then what is the capacity of the load source available, whether it is able to meet the entire drive system. If the load capacity is less, then I have to have some extra arrangement so that it might meet the requirement. Then what is the voltage magnitude which is available at the power source? What is the voltage magnitude if it is required? If the voltage magnitude is less, then I have to put a boost converter accordingly. The voltage magnitude is very high, then I have to put a buck converter accordingly. Then what is the voltage fluctuations? How much fluctuations are there in the voltage that I have to study, and based on that I have to decide my converter. What is the power factor of the power of the source, and is it lagging power factor or leading power factor? Then is there any harmonics present in the source, and whether it is going to affect the load very prominently, that has to be decided, and accordingly I have to select the motor types and converter types. Ability to accept whether the source is able to accept the regenerated power from the load towards the source, and if it is not able to do that, then I have to alter the source accordingly. All these factors decides the decides the component selection. The next is the capital and running cost. The cost of electric motor is also another important factor. In general, DC motors and newer types of brushless motors are the most expensive machines, whereas the squirrel cage induction motors are the most cheapest one. So based on that, I have to decide whether my cost is acceptable for my drive systems or not. Then running cost. If I look at the running cost, induction motor running costs are very less when compared with the DC motors. So based on that, I have to decide. Space and weight restrictions, whether space and weight of the entire drive system is acceptable for the application or not. Say for example, in the case of an aircraft, there should be less weight and less space available. And environment and location. Environment factors may also determine the motor type. The environment, especially in the case of as I told you already, especially in the case of petrol bunks, I cannot use my DC motors, because DC motors have sparkings between the brushes and the commutator segments, which may disturb the entire environment. In that cases, I have to make use of an brushless DC motors in most suited. And efficiency and reliability also makes an important point in the drive selections.